Hello students, this is my next lecture on numerical analysis, lecture 10. In this lecture I will start the new chapter, solution of algebraic and transcendental equations. So let us define first algebraic equations. The equation of the form fnx is equal to 0 are called algebraic if fnx is purely a polynomial in x. That is fnx is equal to a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 plus a n minus 1 x plus a n. And example, simple polynomial equation in x, 3x cube plus 4x square plus 5x minus 8 equal to 0. Transcendental equation. The equations of the form fnx is equal to 0 are called transcendental equations if fnx contains some other functions such as logarithmic function, polynomial function, trigonometric functions, etc. For example, if the equation is like x cube plus log x plus 1 plus cos x is equal to 0, this type of equations are called transcendental equation. So for solving these equations we have to discuss several methods. First method is bisection rule or Bolzano method. So by its name it is clear that bisection means bisecting. We have to bisect the intervals and proceed further. So what is the steps? If a function fx is continuous between a and b, and if fa and fb are of opposite signs, we have to find the value of fa and fb. If fa is positive and fb is negative, that means they are of opposite signs. Then there exists at least one point between a and b at which fx becomes 0. That is, the equation fx is equal to 0 has at least one real root between a and b. So by this method we have to bisect the interval. So let x naught is equal to a plus b by 2. If fx naught, we have to put the value x is equal to x naught in our function. So if fx naught is equal to 0, then x naught is the solution of fx is equal to 0. If fx naught is not equal to 0, then we have to find the sign of fx naught. It is positive or negative. We have to just check. So suppose fx naught and fb are of opposite signs, then there will be at least one root of fx is equal to 0 between x naught and b. We have to again bisect this interval. So let x1 is equal to x naught plus b by 2. Again, if fx1 equal to 0, then x1 is the root of fx is equal to 0. If fx1 is not equal to 0, find the sign of fx1. Now if fx1 and fb are of opposite signs, then there will be at least one real root between x1 and b. Thus we have to proceed as above and bisecting the successive subintervals. Ultimately we will get a solution of fx is equal to 0 after a finite number of steps. So let us take an example. Find the real root of the equation fx is equal to x cube minus x minus 1 equal to 0 using bisection method. So we have to find the value of a and b where fx has opposite signs. So let us start by taking x is equal to 0. So if x is equal to 0, f0 is equal to minus 1. If x is equal to 1, f1 is equal to minus 1. If x is equal to 2, f2 is equal to 5. So for 1 and 2, f1 and f2 are of opposite signs. Thus f1 and f2 are of opposite signs, and hence the given equation has at least one real root between 1 and 2. So let us bisect this interval. Let x0 is equal to 1 plus 2 by 2 is equal to 1.5. Now we have to find the sign of f1.5. So find the value of f1.5. Simplifying 1.5 whole cube minus 1.5 minus 1 is equal to 0.875, which is greater than 0. So f1 and f1.5 are of opposite signs. So there will be at least one real root between 1 and 1.5. Let x1 is equal to 1 plus 1.5 by 2, which is equal to 1.25. So f1.25 is minus 0.296875, which is less than 0. So f1.25 and f1.5 are of opposite signs. So there will be at least one root between 1.25 and 1.5. Let x2 is equal to 1.25 plus 1.5 divided by 2 equal to 1.375. So f1.375 is 0.2246, again, which is greater than 0. You have to compare the value of f1.375 with just previous value, that means f1.25 and f1.5. f1.5 is positive and f1.25 is negative. So there is a root between f1.25 and 1.375. So let x3 is equal to 1.25 plus 1.375 divided by 2, which is equal to 1.3125. So we check that the value of x2 is 1.375 and the value of x3 is 1.3125. We come to the closer solutions. So we proceed for 2 or 3 approximation more. In the similar way, find the sign of f1.3125 and we get the next approximation as x4 is equal to 1.3437, and if we find x5, then we will get 1.328125. So let us compare all these solutions. We have the value in 1.3, 1.3, 1.3, 1.3, 1.37, 1.31, 1.34, 1.32. So we are getting just similar solutions. So we can write that the required root is 1.3281 up to 4 places of decimal. In bisection method, we will find till 5th approximation, means till x5 you have to derive the solution. And one more thing is important. In this chapter, we have to use scientific calculator. In scientific calculator, we can save our time a lot. We just insert the function fx, which is x cube minus x minus 1, and in scientific calculator there is a key written solve. If you press that key, then it asks x is equal to what? You have to put the value of x as 1.5 and you will get the solution. Similarly, the next value, again press solve and change the value of x as 1.25 and you will get another solution. So in this way, scientific calculator can be used in this chapter. write some more questions. Find a positive root using bisection method. X cube minus 3x plus 1 equal to 0. E to the power x is equal to 3x. X minus cos x is equal to 0. So this question can be solved without using scientific calculator, but for this question and this question we have to use scientific calculator, as we don't know the value of cos 1, cos 0, cos 2, cos 3, cos 4 and so on. So by the help of scientific calculator we can find the value of the functions and write the values. And one more thing is important for finding cos and sine. The scientific calculator can be set in radian form, not in degree form. So after lockdown, when the shops are open, you have to purchase a scientific calculator and practice how to calculate these values using scientific calculator.